Computers and Business Communication. Lecture number 7. Jack Barnett 21. There's some revision you need to do on LANs, WANs, VANs and MANs, local area networks, wide area networks, virtual area networks and metropolitan area networks. Bob Metcalf was one of the 4 who put together LANs. But before we do, let's go back to this thing on laser networks, laser printers.
The laser printer. It turns digital documents into printed pages. Very fast. The printer uses a laser. Actually touches the page. In fact, the laser's job is to help create an image of each document. An image made of toner, a powder engineered to stick to the page, thanks to the ingenious use of static electricity. But how does it work? The laser printer, circuit board, laser unit, print cartridge. When a digital document is sent to the printer's circuit board instructs the laser beam to send pulses of light into the print cartridge. That's where a laser beam and static electricity turn a digital image into an image that can be printed on paper. But to find out how, it's time to take it apart. Inside the print cartridge are 2 main components, the drum and the toner hopper. When a print job starts, the drum begins to turn. It brushes against an electrically charged roller that coats the drum's surface with negative charges of electricity. Electricity sitting on a surface. That is static electricity. The drum has a light-sensitive surface. And as it turns, it gets hit by a pulsing laser beam. Wherever that tiny laser beam hits, it destroys a negative charge of electricity. That creates a neutral space on the drum's surface. These neutral spaces are important. As the laser works line by line, zapping the drum 1 million times per second, it creates more and more neutral spaces, until they form an image of the document, right on the drum. For that drum to print the image onto the paper, it needs to fill those neutral spaces with toner. This happens by stirring the toner inside the hopper. The toner is engineered so that the friction from the stirring generates static electricity. A negative charge of electricity sits on the surface of each toner particle. So how does the toner get to the drum? Just outside the hopper, there's a roller that's covered with toner. As the drum turns past this roller, toner has no choice. Since the toner carries a negative charge, it's attracted to the neutral spaces on the drum. It obeys the laws of physics and jumps onto those neutral spaces each time the drum rolls past it. At the same time, the toner is repelled by the negative charges that cover the rest of the drum, so the toner only sticks to the spaces hit by the laser. Now the toner forms a mirror image of the document on the surface of the drum. While all this is happening, the printer is charging a piece of paper with positive electrical charges. The rolling drum carries its toner image down onto the paper. And this is the moment of truth. According to the laws of physics, that positive charge on the paper attracts the negatively charged toner with greater force than those neutral spaces on the drum. That greater force of attraction pulls the toner off the drum and onto the page. Now the image of that text is on the paper. One last roller heats up to 200 degrees Celsius. Its job is to melt the toner permanently onto the paper to create a printed page. The laser printer, an ingenious device. Using the precision of a laser beam to manipulate static electricity, it can print high-quality documents in a flash, as many as 27 pages per minute. That is...
Okay. So let's now move along. Here's a thing by Gary Player, which I think is rather interesting. Mr. Player says, the harder you work, the luckier you get. The brain. In the computer, the CPU is seen as the brain. Alright, I'm going to look at computer basics. I'm going to look at the control panel. I'm going to look at accessories, and then communication sensors, and then communication methods used, which, when, where, and then summary and conclusion. Let's move along. Just look at this assignment. That's how you've got to set these things up. Okay? With the slide, and then your 75 words on each of 20 pages. Please do not miss out pages because they're the title or the contents or the summary. Put 75 words on page, and then hang in the USB stick, your handing form, plastic envelope, a staple, and no viruses please, nothing else. That's the lot. When I start work on a Monday morning, I find that I need to go to the setup, the control panel, because I want to set up the screen in the computer room so that it can be seen from the back. If ever it's turned off, all of the settings are wiped out, and I frequently find on a Monday morning that it has been turned off. Let's have a look at the things that the control panel is going to sort out. What have I got? I've got that lot there. The things that I'm looking at. The performance of my computer. Parental controls. The mouse. Personalization of the computer. Administration tools and internet options. These are all the things that I'm interested in. Other things on the computer that I might use. Paint, well, we've used. The calculator. The address book. Here it is. Internet stuff and the notebook. AVG antivirus program. I put Kaspersky there. There's another one here. You must consider an antivirus program if you're handing in disks. Right. If you go to the start, you've got here administrative tools. Alright, all programs, you've got accessories there, but down here you've got administrative tools. Okay. What are we looking at here? There's the brain. There's a better look at the brain. Here's another look at the brain. But as you see, it says the CPU equals the motherboard. Yes? The CPU on the motherboard is the brain. The motherboard is the body, isn't it? The brain is on there. Let's move along. Now what I was asking people to do today and this week was to look at a number of major items on the computer. Alright? These are the major items. You need to go through some of these and think about them. This one, CMOS, was the CMOS battery. BIOS, basic input output system. Obviously RAM and ROM. But what about transistors? What about vacuum tubes and valves? Look at those. Find out something about the grounding bracelet. Okay, now let's have a look at this.
I get it right there. Computers. Okay, what? Okay.
Oh, hi. Today, we're going to show you what makes a computer work.
Oh, you just plug it up?
What makes a computer work? Well, it's quite complicated, actually. You see, zero insertion force sockets on the central processing unit allow for median distribution of electrons to the GUI and the BIOS.
Now, look, it's not quite that easy, but it's not quite that complicated either. Everything that we have in the technology world is actually based off of something that we knew before, like the human brain, no? What we learned in elementary school about all of our 5 senses. Our eyes are the input. See? Our ears are the input. Our nose is the input. We hope it's not the output. And our mouth, our tongue, our hands, everything that's about our 5 senses is about taking information into the computer that we call the brain. Also, we have output. What's the output? Well, the mouth, when we speak, is the output. And our hands, when we work, is the output. So, what's all that got to do with computers? Well, I'll tell you, the computer is based on the human brain, on the human experience. Now, a lot of people think that this is the computer, but it's not. It's not. This is actually the computer. Here's the brain. This is called the processor, or the CPU, the central processing unit. Just like the brains in our heads, this brain inside the computer on the motherboard actually relies upon input from the outside, and then it gives us, the users, output. We must tell the computer what it's sensing, what it's hearing, what it's seeing. We do that by using things like a mouse and a keyboard. These are input devices that allow us to input information into the computer. Now, once the keyboard and the mouse and any other kind of input devices have put information into the computer, the information has to come to the memory. Then the memory sends all the information that we might need to the brain of the computer, which solves all the problems with lots of calculations. Now, once the computer has taken the input information and calculated it with the brain, then it must output the information to the user. To do that, a card on the motherboard takes the information from the computer processor and sends it out to the user. This allows us to see the information coming out of the computer, just like the printer, when we print, allows us to see the information that comes out of the computer. Input, output, very important. The last thing that we really want to do is create some memories. Without memories, our experience of input and output has no meaning. That's where our friend the hard drive comes in. The hard drive is just like the memories in your head. Remember when? This little thing right here is what stores all of the memories of the computer. All of the files, all the letters, all the things you've ever done on your computer get stored right here. That way, the next time we turn the computer on, we can go right back and do it all over again. Well, my friends, that takes us right back to the old human brain. Now you kind of understand a little bit about how computers work, but remember, Just like going to school, don't forget to read the manual. Hey, the brain needs something to do.
Thank you very much. Let's go back. Now, built-in programs that you need to consider on your computer. Alright? The calculator, the command prompt, MS-DOS, Notepad, WordPad, Paint. But there's also disk cleanup, disk defragmentation, scan disks, and system restore. These are all things that make our system work better. Let's go back up with that one there. Source plus receiver. There's the theory. Communication, it seems to, will have taken place when information sent equals information received. Communication equals information transmission, a message, between the source and the receiver using some signaling system. Communication really equals making common. Human or animal or plant equals passing information between a source and receiver using some sort of signal. Which ones do you use to communicate? Taste, touch, sight, sound, smell? These are all mediums of communication. Which are the best three methods of communication? Do write those down. The best methods of communication: writing, computing, pictures, phoning, texting. Are they verbally? Are they non-verbally? Videoing. Are there any others? What? Telepathy. Let's have a look at this. On-screen communication. The intranet, extranet, mail.
You mean spam,
Emails.
spam, and spam? You mean spam.
Those emails that you don't like receiving. What about memos? Are they a good method? If you get messages on screen, well, there, yes, but then we get spam. Memos. Stick notes. Notice board. Do you read notice boards? What about faxes? Are they a good method of communication? Let's move along. Phones. Telephones. Trouble is, when you're on the telephone you can't actually see somebody. What about mobile phones? You sometimes hear too much breathing on the mobile phones, don't you? Answer machines. Awful. People don't really know what to say on answer machines. Okay. Mobile phones are always available, always used, and texting always there too. Trouble with text messaging is you don't always understand what people are talking about. But some phone messages make it easy. Perhaps. Verbally, face-to-face communication. Is that better than the phone? Now that's the question I want you to ask yourself. Well, look at this. If you see somebody face-to-face, you can pick up much more easily their tone. You can hear the words, you can pick up their voice tone more easily. But then look at that about body language. 55% is body language. And you don't get any of that on the phone. You get that face-to-face. Therefore, those are the are the things to bear in mind. What about non-verbally? What happens non-verbally? Well, you look at the way people dress, and you look at their face, then their shoes, and then the rest of their dress, how they stand, their body language, their facial expressions, and perhaps their cleanliness. Here are a few notes. Judgments about people are made in the first 5 minutes. Well-cut suit equals a high status. Dark suits equals ambitious and socially motivated. Tattoos, are they good or bad? What about body language? It's estimated that 70% of human communication is non-verbal. 70! Body language speaks louder than words, obviously. People believe body language before they believe speech. See, there's attentive behaviour. Nods, listens, encourages. Yes, when you're listening. The body language sometimes in the lecture room. Not always encouraging. Of course, there are cultural differences. Touching females in some Arab countries is considered very impolite. Touching kids on the head used to be acceptable, but it's not quite so acceptable now. Blowing your nose in public is considered very impolite in Japan. Okay. In this thing on communications, I've tried to look at basic communication. I've tried also to look closely at the computer, the way of setting up the computer, the contents panel. I've tried to do it, but you should do it. I've tried to touch on accessories. I've tried to look at a definition of communication, communication senses, and communication methods. Okay, I hope that's been useful. Thank you very much.